All right, I'm going to go ahead and take a second here to explain a couple different things about distance time graphs. So remember that not all graphs are going to follow the same types of relationship that we're talking about. This is very unique to a distance time graph. So you might see some where it's speed or velocity time graphs. Those are going to be a little bit different. We're looking at distance and time because what we're really looking at is speed. And speed is using the distance an object travels and the amount of time it takes. So in this first example, we have a graph here that's not filled out, and we have a little simple kind of word problem. So a car drove 20 miles in 2 hours and then 30 miles in 1 hour. So simply graphing this shouldn't be super complicated. So we know that the first 2 hours, so I'm going to go ahead and look at 2 hours, they traveled 20 miles. So this is in hours, this is in miles, so I'm going to go ahead and go to 2 hours, and I'm going to go up to 20 miles. I'm going to go ahead and make my mark there. All right, so now the trip is not over. I'm going to connect that to my origin where I started, which if this was the case, that'd kind of be my reference point. So now they keep driving, and then for 30 miles in 1 hour, so the traffic must have been a little different. So then they went 30 miles in 1 hour. So for the next hour, which would be hour 2 to hour 3, they ended up going 30 miles. So I'm going to go 1 or 10, 20, 30. And you can see now I'm going to connect that. And what you're left with is kind of this. I'm going to go ahead and erase my counting marks so it's a little more clean. What you'll see here is a graph that has two different shaped lines. Both of those shapes, or angles, or slopes is the proper name, tell you information about that word problem or that object that you were being described. So this word problem is describing an object's speed. Now we're graphing an object's speed, and the next step is to calculate an object's speed. So if I was to look here, this first scenario, to calculate the speed, so we're going to do distance divided by time. And now if you want the average speed, you do the total distance and the total time, but we're going to look at kind of individual segments here. So the distance of my first section of the drive was 20 miles. So I'm going to put 20 miles. The units are important because that tells us what units we're going to end up using. All right, so in the same situation, we went for how long? 2 hours. So now we're left with a relatively easy problem here. 20 divided by 2 means that we are left with 10 miles per hour. So the speed here is 10 miles per hour. All right, so let's just real quick do the second one and see if we can figure that out. So this one only has 1 hour, so our time on this one is going to be 1 hour. So now we're looking at a very easy division problem. All right, so for this one, it's going to be 30 miles, which it's already basically in its unit form here, so we have 30 miles per hour. So if we were to look at this, we have two different speeds happening on this drive. So these would be the individual speeds for each portion of the drive, but if we wanted to find the average, we'd have to do the total distance and the total time. So now I'm going to do the total distance divided by total time, and that's going to give, let's find out. So our total distance was 20 miles and 30 miles. So 20 plus 30 miles, and our total time was 2 hours and 1 hour, so 3 hours, which we're going to be left there with 50 miles in 3 hours, which if you were to do the math, it ends up being kind of a not even speed, but you still do 50 divided by 3. You don't swap it around just because the numbers are bigger or smaller. You do what the equation tells you. 50 divided by 3 is going to give us, basically, we're going to round up to 17. So I'm going to, sorry, this is kind of sloppy. I'm going to go down here with my equal sign. It ends up being 16 0.6 repeating. So basically, in this one, you're probably not ever going to get a question on a test that's going to give you some random speed like this. But in general, we just saw that this would be our average speed. This would be our individual speeds for different parts of the trip. So they're not the same number because this takes all of the trip and splits it evenly, whereas these are both looking at what's going on. So even looking at this graph, you can see that the faster speed and the slower speed, there's a certain trend you see with the line itself. And we're going to look at that in the next one and see if we can build on that. All right, so the next question. We have a simple graph right here. There's literally no units, and there's no units down here. It's just distance on this side and time. So it's still giving us the relationship, or it's describing the speed of an object, just not with units that we can calculate. So in general, we have A, B, and C. And even without the numbers here, we can tell which one of these is the faster or the slower. And we're going to use, at first, we can sit there and calculate all kinds of stuff, and we can make up numbers and see if they end up calculating properly. But we also, if we took away this concept, we notice that when it's slower, it goes a little, it's like, it's kind of steep. But when it gets faster, it goes even more steep. So if you look at these three, one of them is steeper than the other two. That's going to give you the answer to which one really is the fastest. Because the question, when you say which is the greatest speed, they're not asking you which one went further. They're not asking you which one went the longest time. They're simply, because this one, they're all over the place. This one, they're simply saying, while that object was in motion, was it faster than the other objects? So B might have gone for a very long time because it went longer time than everybody else, but it really went about the same distance as A. And if you were to take this abstract graph and make it into, let's say, you and your friend running in your neighborhood or at school, if you and your friend ran about the same distance, but you ran it in half the time, you probably went faster. I think that you most would realize that. So really, in a situation like this, you're simply looking for the steepest line. The steeper the line means you're covering more distance in a smaller amount of time. So if I wanted to make a line on here that was even faster than the rest, I just have to make a steeper line than any other one. So that's even steeper. So in this, let's make this D. In this one, it's going really very short amount of time and a pretty decent amount of distance. So if you were to calculate all of these out with actual numbers, you would see that this is the fastest, second fastest, third, and then slowest. All right, so now let's look at our graph here. So now this time we actually have numbers. We're not just going to use relative speed. We're going to use the actual calculation. So this is saying what is the average speed. So if you remember up here, our average speed is total distance divided by total time. So let's go ahead and look at this. What was our total distance? Well, it went 600, our units are meters. So let's do 600 meters divided by, what was the total time? 6 seconds. Look at that. The numbers just happen to be really easy to divide. Who would have guessed? So we have 600 divided by 6, which would be 100 meters per second, which is quite a fast object. So in this, you were able to get this information from the graph. And technically, anywhere on this line that I take the coordinates of, I'd get that number as well. And if you don't believe me, let's go ahead and try 3 seconds. Goes up, it intersects right there. So I'm going to use this point, which is already on the line. And let's say, so its distance is 300. Time is 3. What do we see? It's still 100 meters. So any coordinates you take, if I do 1 and 100, 2, because this line is straight the whole way through the same slope, it's what's called a constant speed. So anywhere on this line, if you calculated the speed, it would be the same throughout. Now a changing graph looks a little different. This graph, still distance, still time, it shows different varying speeds. Now, if you remember what we saw in our first scenario, we can determine the fastest without even doing the calculations just by looking for the relationship between the slope and the speed. So the steepest line up here is going to be the fastest. This line right here looks way steeper than all the others. Not way steeper, but steeper than the rest. So it's probably the fastest. Now we could calculate all this out, but if the question said which section, let's say this is 1 through 4 seconds, this is 4 through 7, and this is 7 through 9. You might see a question where it says, during which portion of the race or the experiment was the object going the greatest speed? Between 1 and 4 seconds, 4 and 7 seconds, or 7 and 9. You could calculate the whole thing out, but you could also answer the question really fast by simply saying, this is steeper than the other parts, so I know it's faster, so I'm going to pick the one that says 7 to 9. Now, if you're more comfortable taking these numbers and calculating it out, you can see that it started at 50, it went to 90, so that means the total distance of that one was 40. The time was 2 seconds, I believe. Yeah, 7 to 9. So that's going to give us 40 divided by 2 is going to be 20 meters per second. So that one goes to that section. Let's take this section and see what it gives us. So this would be 4, 5, 6. So those seconds there, we have only jumped up 10 meters in 1, 2, 3 seconds. So that's going to give us one of those weird speeds, but 10 divided by 3 is not super hard, but it's going to give you a decimal. But either way, you can see that it's going to be a smaller or slower speed. All right, so then our final section, just to calculate it out to see if our little trick of looking for the steepest makes sense. This one covered 40 meters. So same distance as the first one, but this time it took 4 seconds. And I think most of you, like I said, if you and your friend both ran the same distance and one of you ran it in half the time, you probably can figure that out. So this is 10 meters per second. So you can see that the kind of steep one is kind of fast. The not very steep or almost horizontal is slow. And the steepest one is the fastest. So you can sit and calculate all that out using this if that makes you comfortable, but also using the pattern, the relationship between these, you can simply look at how steep the line is. Now once again, this is a unique type of thing that we're looking at distance and time graphs. It wouldn't necessarily be the same relationship if we had a different type of graph. So to kind of review looking at this, we started looking at, we can take a word problem and we can graph it. We could use that word problem to calculate the speeds. We can look at the steepness of the line to kind of also get a general feel for if it's steep or faster or not. Looking at this one, we saw that even given a situation like this, even if there were numbers, it wouldn't matter. You look for the steepest line, that will be the fastest moving object for the time it was going. Now, if they asked you which one went the furthest distance, technically it'd be B. It went the furthest distance and time, but it took a long time. All right, so this one, calculating the average speed, you take the entire trip and calculate it by the entire time to get your average. In this picture, this is a constant speed, so anywhere on that line, you're going to have the same speed calculated. But if you had a graph more like this, this shows changing speed, which means that it's has an unbalanced force. There's acceleration going on. It's either slowing down or speeding up. We're not going to talk about what the downward type of slope would mean. I mean, a negative slope would mean, but we'll do that tomorrow. So today, your goal is to be able to look at some word problems and figure out the speed. You should be able to possibly decode a distance time graph using both calculations, but also the relationship between the slope of the lines. So good luck and answer those questions the best you guys can.